Alright, what is up year 12? I want to talk about this question 1, that's from the worksheet you were doing today in class. So I'll read it first in case it's too small. A pebble is thrown horizontally with a velocity of 40 meters per second over a cliff 125 meters high. What that actually means is that the cliff itself is 125 meters high and you're on top of it. So let's draw the cliff. It's always important to draw pictures of what's going on to help us understand it. And then we can also label some stuff here. So this is the height of the cliff. Just draw that as an arrow. This may take a little bit of time occasionally to draw stuff out, but it's worth it in the end. So this is 125 meters. I guess I'll move that over about there. And it's coming off with a velocity of 40 meters per second. Actually, I've got arrows here. Let's use one of these. Let's do a nice green arrow to represent the velocity, which is entirely horizontal. Okay, so let's label that on there. 40 meters per second. Cool. And that's all the information that we begin with. Now you can see over here on the right, I've already written out suvat twice. Why have I done it twice? Well, one is for vertical, V, and one is for horizontal, H. So let's stick that there. This is always the first thing you should do. Draw a diagram, write out suvat for vertical and horizontal. You might not use both, but we might do. So let's have a look. First of all, let's fill in what is going to happen and what we're going to know about. So this will follow something called a parabolic path. And that looks a little bit like a curve like this. I can draw that and then tweak it a little bit like that. That's going to be the path that it follows. Now you might think, okay, so it slows down horizontally, but no, what's actually happening is it's getting faster vertically all the time, and that makes it makes the line bend, right? Because it's got a steeper gradient the further on you go. It's going faster here vertically than it is here vertically because it's accelerated due to gravity. So let's try and fill some of this stuff out. So from the start up here down to the bottom, what can we write? Well, the first thing, let's do it in blue. The first thing is the displacement vertically. I'm going to choose downwards as my positive value today. So let's write that here and label it. So this is positive. Downwards is positive. So let's write down what we know. So displacement is going to be 125 meters. Important to put your units in there. The initial vertical velocity is 0 meters per second. The final vertical velocity is unknown. And the acceleration due to gravity is 9.81 meter per second squared. I guess I'm going to need to make my text a little bit smaller. Let's drop down to 20. 9.8 meters per second squared. Okay. Notice that it's a positive value because I chose downwards as positive. Finally, the time, I don't know. Okay, so let's bring all of this just over here a little bit so we've got plenty of room. Now, for the horizontal, in fact, let's change the color of the horizontal. Let's make it purple. Purple's nice, like that. Ooh, almost. And we'll do our text in purple so we can keep track really easily. So purple, do I know how far it goes horizontally? That's going to be... where can I draw an arrow from? That's going to be this distance here, or this displacement. Do I know that? The answer is no. At the moment, I don't know that. I'm sure I can work it out, but right now I've got no idea. So I don't know that. Do I know its horizontal velocity? Well, yeah, I do. That's 40 meters per second. So let's fill that out there, 40 meters per second. Do I know its final velocity? Well, I do, and the reason I do is because its acceleration is 0 meter per second squared. The reason for that is there is no horizontal force acting. Yeah, there's air resistance, but we ignore that in A-level physics. Finally, do I know the time? No, I don't. So I look at vertical and horizontal and I say, well, I know a little bit more information about the vertical, so I'm going to use that to try and solve this question. So the first thing it asks me is how long it takes to reach the bottom. So I'm looking for t. I'm going to try and find out what t is. Let's highlight that. T is what I'm looking for here. So I've got 3 equations, haven't I? I've got v equals u plus at, s equals ut plus half at squared, and v squared equals u squared plus 2as. I don't really think, can I Google those? I guess I could. I don't really think I have time to, or I don't think it's convenient for me to write them all out. Let's get the equations of motion and see what we find. There might be an image that will show us. have a look. Now there are of course more than just the 3, but I only really use 3, and I've always found that to be enough. There are a couple of extras. Come on, school internet. You can see them here if they ever load, and we'll see if we can copy these across. Copy, and we'll put them in. Oh, wonderful! That looks fantastic. Print screen it maybe. That's not going to work either. Okay, well let's just refer to them here. So we're going to be using one of these. So let's have a look. What have we got? We've got S, we've got U, we've got A, we've got T. So I'm going to need S equals UT plus a half AT squared. Where is it? This one, number 2. S equals UT plus half AT squared. This is just simply plugging the numbers in. And because U is 0, I'm going to get, let's try and write it. I'm going to get S equals a half AT squared. And that's because U is 0. AT squared. Boom. Easy. Now I've got to rearrange for T, which is one of the equations in the first assessment, and that's going to be T equals the square root of 2S over A. Now I'm going to need my calculator, and I'm going to plug the values in. So 2 times S, divide by A, 9.8, and square root it. I'm going to get my answer to be, answer, 5.05 seconds, which I remember being the correct value from one of our students getting it. So 5.05 seconds. Remember to make it clear that you work this out separately. You know, I've done it in a different color, I've done it in gray. I worked that out, it wasn't given in the question. So we've answered the first bit, how long will it take to reach the bottom? Now, how far from the bottom of the cliff will it land? Let's get rid of this calculation. How far from the bottom? Well, I'm going to use the same equation, S equals UT plus a half AT squared, but this time acceleration is 0 because there's no horizontal acceleration. Zoom right in on that. So it's going to come S equals UT, which is distance equals speed times time. So we've got S equals U times T. Now, do we have T? Well, yeah, we do. It's this value here. Let's copy and paste it, stick it over here. The time taken for it to fall vertically and for it to travel horizontally and combine together to do this nice parabolic path is 5.05 seconds. So it's the same for both. So now I just do S equals U times T, 40 times 5.05, do that on my calculator, and that's going to give me a displacement of 202 meters. 202 meters. Okay, so that is my final solution for the question. I'm going to, of course, underline my answers so that the examiner can see very clearly what my final solutions are. Hopefully that makes sense. If you've got any questions, then please ask on Edmodo.